Let us have this question, which reads, the letters A to H in the table below represents 8 organic compounds, that is from A to H. So this type of question, before you even start answering this, you must be able to identify what you have from A to H. So if you check the first one, if you check the functional group here, this one, it's COOH. So this is the functional group for carboxylic acid. We haven't answered any question yet, but we just want to see what we have before we start answering. So A is a carboxylic acid. Let's go to B. B, we have a double bond here, which is an alkene. We go to C, we have this part, COC. So this means we have a double bond here and attached to carbon on the left and right. So this is a carbonyl group. So this is a ketone here. Then D, C2H6O. This is just a molecular formula. We don't know the correct arrangement of these atoms. But which molecules have one oxygen? Examples, we have alcohols. An alcohol has only one oxygen. So in this case, we may assume that this is an alcohol. Then let's go to E, C2H4. This one is an alkene. From the general formula of an alkene, we know that CnH must be twice the number of carbons. So this is C is 2, then 2 times 2, we get a 4. So this is an alkene. And then F, 3-methylbutane 2-on. This one, ketones, they end with the suffix ONE. So this is a ketone. Let's go to G. G, we have chloride, and the methyl. But the methyl is just a subchain. Then chloride is the substituent. So this is an alkane, but it has the halogens. So this is going to form a haloalkane. Then H is 3-methylbutanol. We know that aldehydes, they end with suffix, which is Al. So that's an aldehyde. So now let's go and answer the questions that follows. 2.1, define the term unsaturated compound. What is an unsaturated compound? This is a compound that consists of multiple bonds between carbon atoms. So I'm just going to write it down here. A compound that consists of multiple bonds between carbon atoms. That's how you define unsaturated compounds. So here's the example. Multiple bonds that we are referring to, it can be double bonds for alkenes. It can be triple bonds for alkynes. They should be between carbon atoms. 2.2, write down 2.2.1, the letter that represents unsaturated compounds. So unsaturated compounds are either alkenes or alkynes. So in this case, we have already figured out that B is an alkene. So this is the one which is unsaturated. So we have letter B for this one. That's for 2.2.1. Then for 2.2.2, name the functional group of compound C. What is compound C? This is our chain for compound C, CH3, CH2, CH2, COCH3. So here is our important part where we have our carbonyl group, which is the one I showed you earlier, this one. We have the carbons that are attached to the left and right of this middle carbon. So this is a ketone, and the functional group of a ketone is known as the carbonyl. So let me write the answers here. 2.2.3, letter that represents a chain isomer of compound C. What are chain isomers? They have the same molecular formula but different chain structure. Means that's when you can have a straight chain and a branched chain. So they are saying for which compound? For compound C, which is this one. Let me draw it here. Maybe we can clearly see what's going on there. So we have CH3, we have CH2, CH2 again, C double bond, O, then CH3. The rest are hydrogens here. So we want to see what could be our chain isomer here. So let's try to form a branched chain here. So what we can do here, we can take this one and place it on this carbon. We're going to have a branch. So this is what we're going to have. 1, 2, 3, 4. Then we have a double bond here. Then we can put our branch chain here. Then the rest are hydrogens. If it's an isomer, you must have the same number of carbons and the same number of hydrogens. Let's count number of carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Carbons are balancing. Let's check hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's balancing. So this is what we have as our structural, as our chain isomer. But we need its IUPAC name. Maybe it can make it easier for us to identify it from the table. So if you check here, by numbering our carbons, we can start numbering from right to left. 1, 2, 3, 4. So our methyl is this one, is a branched chain, is on carbon number 3. So that is going to be 3-methyl. Then the main chain is 4 carbons, that is going to be butane. Then our functional group carbonyl is on carbon number 2. So that is going to be 3-methyl butane 2-on, which is this one. So that's F. So we have answered 2.2.2. Sorry, it's 2.2.3. Then let's go to 2.2.4. 2.2.4, it requires the IUPAC name of compound G. So here's our compound G. So looking at this compound, we need to identify our main chain as well as our subchains and substituents. So our substituents, we have this, the chlorides. Then we also have this as our subchain or the branched chain. So let us see how we can number this. You must number carbons from the outer carbon which is closest the substituent or the branched chain. So another rule that you need to apply, you must use the side that gives you the lowest numbers. So it's either you can do it from left to right and right to left, but now you have to check which one gives you the lowest in numbers. So let us see how we can do it. I'll start numbering from left to right and check which one is the best name for us. Then I'll do right to left again. So by starting from this side, this is our carbon number 1, 2, 3, 4, 5, 6. What we have here is the methyl and the chloros. So what comes first, methyl and chloro? Obviously that's a chloro. But we have 2 chloros which is on carbon number 2 and carbon number 5. So we're going to say 2, 5 di, because there are 2, so we say di chloro. Then now we go to the methyl. Our methyl is on carbon number 3. So it's 2,5-dichloro 3-methyl. Then our main chain now will determine the last part of the name. We have 6 carbons in our main chain, so it's going to be hexane. So the full name here is 2,5-dichloro 3-methyl hexane. That's the name that we have when numbering from left to right. Let us see what we're going to get if we number from right to left. So this one will be our carbon number 1, 2, 3, 4, 5, 6. So we still start with the chloros. So this one, our first chloro is on carbon number 2. The other one is now on carbon number 5. I'm using these numbers at the bottom. So we're going to start at 2. Again, chloro is on carbon number 5. So it's going to be 2, 5, which is dichloro again. You'll notice a slight difference here. Then now, what about our methyl? Our methyl is now on carbon number 4. So that's going to be 4 methylhexane. So these are the two possibilities that we have. But which one is best here is the one that have low values. So you can see this one now is giving us a 4 and the first one is giving us a 3. Here is the same, it matches. So there's no problem here, but here that's where we are going to look at so that we can see which one is the best. So this one is out. So we consider 2,5 dichloro 3 methyl hexane. 2.2.5 General formula of homologous series to which compound E belongs. Compound E, this is an alkene, they need its general formula. We even did it earlier. This is CnH2n. Number of hydrogen is twice number of carbons. 2.3 Define the term functional isomers. These are molecules of the same molecular formula but different functional group. I will define it here. Molecules with the same molecular formula but different functional group. It is wiser for you to know which compounds form functional isomers. If two molecules are functional isomers, the homologous series is totally different. In your curriculum, it's only 2 pairs that we have. So we have carboxylic acids and esters. They form functional isomers. We also have aldehydes and ketones. Let me write it here. They also form functional isomers. So it's only these 2 pairs that we need to focus on, either carboxylic acids and esters or ketones and aldehydes. Don't mix up the two. Carboxylic acid cannot form a functional isomer with an aldehyde. It should be strictly esters. And aldehydes can form functional isomers with esters. It's strictly ketones by just shifting the position of the functional group. We'll see that. 2.4.1 For compound A, write down the homologous series to which it belongs. Compound A, this one, we can see this functional group is the carboxyl. So it falls under the homologous series will be carboxylic acids. That's our answer. Then 2.4.2 Structural formula of its functional isomer. Its functional isomer for this. So let's see how we created this. So here is the thing. Carboxylic acids always have the functional group on the outer carbon. As soon as the functional group goes inside, then we are going to form an ester. This is the rule that you just have to remember. Carboxylic acids always have the functional group on the outer carbon like this. So to make it an ester, you just have to flip it, which means this oxygen now is coming inside. Then the hydrogen will be at the end. So here is it. It looks like this. Here we still have our CH3 here. Hydrogen. Then we have our oxygen in here now. Then the carbon, double bond O, and our hydrogen. This is it. That's our ester. In case you may need to know how to name this ester, it's derived from this alcohol side is this side without a double bond. And the side with a double bond is our carboxylic acid side. So this is methanoate. I'll do a video on how to name these esters in detail. 2.5 Compound D undergoes dehydration reaction. Write down the IUPAC name of compound D. So already we're told that D goes under dehydration. So in your mind, you must recall which molecules or compounds that go under dehydration. That is alcohols. Remember, we already tried to predict the homologous series of this one, and we say it is alcohol, and it is because that's the one that we know it goes under dehydration in the presence of a concentrated sulfuric acid. Then write down the IUPAC name of compound D. So this is going to be an alcohol which has 2 carbons, 1, 2. That is going to be like this. Then we have our hydroxyl group, and the rest is the hydrogen atoms. So what is the IUPAC name of this one? Only have 2 carbons, so this is ethanol. In this case, the position of the functional group is not that important, because even when you put it here, it will be ethan 1-O or 1-ethanol. Even when you place it in either of these 2 carbons, it will remain ethan 1-O or 1-ethanol. So the position of the functional group is not important in this case. But on 3 carbons upwards, it's important to mention the position. Then 2.5.2, you need to write down the letter that represents a product of this reaction. Which reaction are we talking about? It's dehydration. So if you dehydrate an ethanol or an alcohol, what are you going to form? We know that we're going to dehydrate this, or that's what we're going to eliminate, the water. And a double bond is going to be created here. So you have C double bond there. Then you have your hydrogen here, hydrogen here, hydrogen here, and there. So we have formed C2H4. So we have formed an alkene. So if you dehydrate an alcohol, you form an alkene. So which alkene is formed here? Is this one, C2H4. So the letter of the compound is E. As simple as that. Then 2.5.3, the question is asking to name or write down the name or formula of inorganic reactant that is used in this reaction. I have already mentioned it earlier that to dehydrate alcohols, you require concentrated sulfuric acid. So the formula is H2SO4, but should be concentrated.